We're looking for something like 1 over x plus 1 over y equals 1 over 4. We want to know what is 1 over x and what is 1 over y. So you'll notice that in fact 1a actually has 3 questions within it. We're going to do this for 1/4, we're going to do it for 1/5, and we're going to do it for 1/6. Let's see, 1 over 12 plus 1 over 3 equals 1 over 12 plus 4 over 12 equals 5 over 12. This does not equal 1/4. So that gives us 3/8. All right, why don't you try it? 1/6 and 1/12? Excellent. Good, and now 1/5. Now, you got perhaps a little bit lucky with 1/4 and 1/6 by using a guess and check approach. If you look at the question, they give you 2 examples. There's a pattern which you should be able to find in these 2 examples, which should make it easy for you to find 1/5. Good, that's right. 1/5 will be equal to 1/6 plus 1/30. Having recognized that pattern is going to be critical for doing question 1b, where we need to show that all unit fractions can be written as the sum of 2 unequal unit fractions. What we need to do is we need to show that that pattern will always work. Now in maths, when we want to show that something works for all cases, we don't use numbers, we use letters. What? Did you just say that? Oh, I'm shocked. Instead of 1 over 4 or 1 over 5 or 1 over 6, let's say 1 over n. That will be equal to what? What's the first fraction we'll put on this side? 1 over n plus 1. Good. And then what will this fraction be? N times n plus 1. So what we want to do is we want to do some algebra with this right-hand side and show that it's all going to simplify down to this. Now, this algebra is a little bit above your pay grade, so I'm going to sort of walk you through it, but I will be asking you for some advice as we go. So for example, we have 2 fractions here. If we want to add 2 fractions, what is required? We need them to have a common denominator. Normally, what do we do to find a common denominator? Suppose we had 1/3 plus 1/6. What would the lowest common multiple of 3 and 6 be? Now we can think about this. We can say, well, that's like 1 over 3 plus 1 over 2 times 3. What's missing from 1 over 3 is this factor of 2. We're going to apply the same logic up above. We're going to say what's missing from this n plus 1 is a factor of n. That means we're going to have to multiply the denominator by n, which means we're also going to have to multiply the numerator by n. This becomes n over n times n plus 1. And so if we add these, we have the denominator being n times n plus 1. What's our numerator? Excellent. We can do a step of simplification. Our denominator has a factor of n plus 1, and so does our numerator. We can divide the top and bottom by n plus 1. So n plus 1 divided by n plus 1 is just no. What's anything divided by itself? Good. So our numerator becomes 1. And our denominator, well, we're dividing out the factor of n plus 1, so we're just left with an n. This is exactly what we were hoping to find. We were hoping to show that all of this would end up simplifying to being equal to 1 over n. So no matter what number n is, we can show that there will always be two unequal unit fractions, which are defined by 1 over n plus 1 and 1 over n times n plus 1, where the sum of them is equal to 1 over n. That was fun.